Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, in the previous class, we have already discussed about the acceleration due to gravity, what could be its possible value, and we have also shown how to calculate the value for the acceleration due to gravity. And we have said that this factor, acceleration due to gravity, remains almost same over all the places on the Earth's surface. There is slight variation, but we do not need to take into consideration those variations right now. Okay, so with that, let us move on to the next topic. Today we are going to discuss about the free fall of a body. So what is actually meant by free fall of a body? What you understand by the free fall of a body? See, so take out your pen and copies and please write down the note heading free fall of a body. So what is first of all meant by free fall of a body? Okay, so you see, when you just drop a stone from the roof of your building, okay, what happens? The stone starts falling, and after some time it just goes on to hit the ground and it stops. So any object, you have seen that whenever you just drop it, instead of does it go up? No, never this. It always comes down and touches the surface of the earth. So basically, many of you must have heard about that Newton doing certain experiments like this. Yes, and that was true, and that was the concept that he developed, that actually earth is attracting every object towards its center, and we know that force is called the force of gravitation, and for this case of earth, it is specifically known as the force of gravity. So when you are considering the free fall of a body, see, you have, while we are studying the motion chapter, we have three equations of motion. What are those three equations? Those three equations were V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. These are the three equations, isn't it? Three equations. Now, these three equations can be applied to a body which is falling freely under the force of gravity. How? Say, consider that when the body is falling freely under the force of gravity, what is the acceleration acting on the body? Think of this like that the force acting on the body is actually the gravitational force. So due to the gravitational force, you know by now that due to gravitational force, when a body falls under the force of gravity, it is accelerated, its motion is accelerated by a value of 9.8 meter per second square. That is, with each second its speed is increasing by a value of 9.8 meter per second, or rather, under simplified terms, you can say that the speed is increasing by a value of 10 meter per second with each second increasing time. Okay, so that is the concept. So when the body is falling freely, definitely the acceleration that is acting over the body is actually the acceleration due to gravity. Is the acceleration due to gravity. Okay, due to gravity. So this is the very basic concept that you need to understand. Acceleration due to gravity. Okay, and so whenever you are doing certain calculations involving these things, what we do, we take the value of A to be equal to G. So take this A equal to G whenever you are doing calculations for a motion of a body under free fall. And so how these three equations will be modified? So definitely these three equations, in these three equations, instead of writing A, we will be now writing G. So just you can just modify these values here. Okay, modify these values here. So what will be the values that we will be substituting it? Here is G, here is G, and again here is G. Okay, so this is how the equations of the motions get modified. Now if you think of such that a body is dropped from a certain height, obviously what happens, just think of it a little bit practically, that when a body is dropped from a certain height, initially you are holding this pen in your hand and you drop it. So before dropping it, what happens? Before dropping it, the pen was at rest. Before dropping it, the pen was at rest. So while doing calculations, we must consider that the initial velocity of the body to be 0. So when you are considering that a body is falling freely under the force of gravity, so you can simplify these equations like this. So when you are saying that a body is dropped from rest, okay, so when you are saying that a body is dropped from rest, okay, you are holding it in the hand and suddenly you leave it, dropped from rest. In under that condition, these equations can be written like this, that v, the final velocity with which the object touches the ground, will be equals to only gt because u is 0. S, the height through which the body falls, is equals to only half gt square, and the final velocity v square will be equals to only 2 gs. So these are the three equations that you can actually directly apply while solving for the motion of a body under free fall. That is, when you are dropping it from rest, when you are just dropping it from a certain height, it is being initially at rest. So these are the equations. Okay, so we will be doing some numerical problems using these formulas. So when we will be doing those problems, you will be having a better understanding of how to apply these equations and how to get the solutions. Okay. So now let us quickly move on to the next topic. So we will be discussing briefly about the mass and weight of an object. Mass and weight of an object. Okay. So mass and weight. So I think this concept is clear, and the concept, if there is some doubt in your mind, I think it will be better to see the lecture in which we will be doing some numerical problems, and if you see the solutions of these problems, it will be much more easier for you to grasp this concept. Okay. So now let us consider what is mass and weight. So mass and weight. What are these two things? Very often we actually use these two terms, mass and weight, synonymically. That is, we use, instead of saying mass, we say weight, or instead of saying weight, we use mass. But actually, when you are thinking it from the point of view of physics, and you are already having a knowledge of the Newton's law of motion and Newton's law of gravitation, these two terms, mass and weight, are not definitely the same term, they are the different terms. Now, how they are different? Just think, you have the concept of mass, that is, in the lower classes you have read that what is mass? What is mass? The amount of substance present in any matter. So mass is nothing but the amount of substance present in a matter. That is simply the mass. Okay. So the more the amount of substance present in a substance, more the amount of substance present in a matter, so more is mass. That is a simple explanation. That is the mass. Okay. Or you can say, rather simply say, the more the molecules are present in that particular amount of the matter, the more is the mass. Okay. But so what is weight? So mass, you can understand that it is the amount of the substance present in the matter. Fine. Now what is actually weight? So this mass. Okay. Before moving on to weight, just let me say, remind you one thing, that this mass is actually constant for a body. This mass is actually constant for a body. That when a body is, say, kept above a mountain, or when that same body is just kept above the sea level, or when that body is just taken from India to, say, USA, whatever is the place, okay, if it does not deteriorate, if that object does not deteriorate, then definitely the mass of that object remains same. It does not change. And obviously mass is, there is nothing to do, direction has nothing to do with this mass. So this mass is actually a scalar quantity. You have already a knowledge about scalar and vector quantities. So mass is obviously a scalar quantity. Now if we consider this mass, that then we must be thinking of that the mass should not be changing. It actually remains constant with space and time. Okay, fine. But actually there are certain cases when the mass of a body can change, but that is not that is out of scope of our syllabus. So basically Einstein has given a certain equations. Some of you may be knowing this equation, E equals to mc squared. Okay, so according to this equation, actually mass of a certain body can change. Okay, can change, and there is something called rest mass and mass under motion, rest mass and mass under motion. So mass can definitely change for certain bodies, but that is not for macro objects like we human beings or any car, any truck, bus or any vehicle or say even a stone. It does not matter for the small objects. Actually, when the mass keeps changing or when there is a change in the mass happening, it is when a substance can travel at a speed near about to the speed of the light. Then comes the question of there is a change in the mass. Okay. Otherwise, if a substance is traveling say with a speed of 100 km per hour, 500 km per hour, it doesn't matter. That speed is quite less in comparison to the speed of light. So definitely in that case, under that situation, the mass of the object does not change; it remains the same. Okay. So with that we will be thinking of now what is weight. Then what is weight? Now see, as already studied or as we have seen that Newton proposed that every object in the universe is attracting every other object. So does the Earth. Earth is basically attracting every other object present on its surface towards its center. Okay. So what is weight? Weight is nothing but this force of attraction. The force of attraction that the Earth is exerting on each and every body, okay, present on the Earth's surface, that very basic force is the weight. So weight is nothing but the force of attraction exerted by the earth on each object. It may be large, it may be small, each object present on the earth, okay, so present on the earth is called its weight. Okay, so force of attraction exerted by the earth on each object present on the earth is actually the weight. So weight is nothing but the force of attraction exerted by the earth. Now see, when we are saying that the force of attraction exerted by the earth, it is actually in a particular direction. Yes, definitely in a particular direction, and that force of attraction is towards the center of the earth. So this weight is definitely a vector quantity, as it has a definite direction, a particular direction. So it is a vector quantity. You must remember that weight is a vector quantity. Now SI unit of mass. What means SI unit of mass? The SI unit of mass is actually kg. SI unit of mass is actually kg, and in CGS it is gram, isn't it? So what will be the unit of weight? See, weight is actually force. So what is the unit of force? SI unit of force is Newton. And what is this? What is the series unit? Series unit is dyne. So Newton and dyne will be the two units of weight. Okay, fine. Now there is another unit used for expressing the weight of an object. It is said kgf. It is kgf. So what is kgf? What is 1 kgf, or how it is related to Newton? Okay, the SI unit. See, kgf is nothing but it's a force. It is that force which is acting on a body of mass of 1 kg. Simply, it is a force of attraction exerted by the earth on a body of mass 1 kg. That is basically the 1 kgf. Okay, and it is saying that if you hold a object on your hand, which has a mass of 1 kg, okay, you need to say this red pen has a mass of 1 kg, and here I am holding it on my hand. I need to apply a force of 9.8 Newton, about 9.8 Newton or almost 10 Newton on this object in the upward direction to prevent it from falling or to prevent it from going towards the center of the earth. Okay, so 1 kgf is actually equal to 9.8 Newton, which can be approximated as 10 Newton. So this is the unit kgf, and this is how it is related to the SI unit of weight. Okay, so these are the units. Now so I think the concept of mass and weight is clear. Fine. Now, so the topics that were left out in this chapter have been completed. In the next class we will be doing some numerical problems, some specific numerical problems, 3 to 4 numerical problems. Okay, and we will be concluding this chapter. If you have any doubt, any query, please do mention in the comment box. We will be happy to solve your problem. And you have a small assignment for you. Please try to find out the differences between mass and weight, and if you can actually say out the differences. Okay, so on your own it will be good for you. Okay, so till then, please study well, and in the next class we will be solving numerical problems. So till then, thank you, goodbye.